In this exercise, we want you to identify counties that have parks or forests, and we've given you a list here of county recreational features and the type. So in Alameda County, for example, there's a reservoir, ocean, reservoir, and reservoir for different features within that county. And same thing for Alpine County or Amador or Calaveras. The problem is you can't just link this because it would be a many one-to-one relationship with the California table. So if I did a join on this county name item, there'd be multiple entries perhaps for Shasta County. I wouldn't know which one I would get. So I have to identify a way to get only those elements of the park or forest pointing towards the road that is associated with each county, and then I can identify those counties that have a park or a forest. There's lots of ways to work this problem, but perhaps the simplest way is to open the attribute table and to select those attributes, those rows, based on the field values where the type is equal to a forest or the type is equal to, order parts, I don't know why that comes up, or the type is equal to, and this is always fun, park. So type equal forest or type equal park. Now when I select those, I see then that I only have features that are parks or forests selected. So I can, with that set selected, right-click and export the selected features as a geopackage in my usual place, Lab 8. I'll call this Park or For tab for my Park or Forest table. I make the geometry type no geometry, and then this invalid projection doesn't make any impact. This no geometry means I'm only asking for the output of the table, and so when I run it, I get this park or forest table, and if I open it, I see that clearly there are only parks or forests in this type. Now, when I do a join, it still is an ill-considered join because I'll have two values here, so it's a many-to-one join on the county name Colusa to the Colusa in Cal, but it doesn't matter. Whichever one it picks, it's going to come through with the park or the forest. So for the type, I'll have a value, and for any county that doesn't have a match, then there will be a blank for the type or a null for the type, so we can see that here when we do the join. So if I go ahead and open the properties on Cal, and I go to the joins, and I add a new join, the join layer is park or for tab, and I'm going to use the county name, and the target field is going to be the county name. So if I say OK and apply it, then I get this joined attribute table. When I look over at type, type has null for the park or for. So any of those that have a value here have a park or forest, any of those counties that don't, and I note that I only have one entry for each county. So I can then create a variable that I index on this, or I could just color based on this and give the park and forest the same color to produce the map I want. I could add a variable and just give it a 1 if it's forest or park, and a 0 if it's null, and color based on that. So I can create the map I wish to create to show which counties have parks or forests. Now there's a couple of things that are goofy about this. One is I'm doing a many-to-one join because I know the error that it results in won't ruin my analysis. The other thing is I'm doing a join here on the county name, which is an alphanumeric. You really usually don't want to join on text, but the way this problem is posed, I would have to go find a FIPS code for each of the county names and then enter that in the rec table and do whatever manual entry I had to do there. So this works in this case. I don't get any mismatched joins because the names have exactly the same capitalization and number of spaces. Otherwise, it might not work if you do a join on a text variable. So anyway, that's one approach. You often have to know the data, know the kind of errors that occur, know what joins do to be able to do a join efficiently.